Fractions in the real world. We see fractions everywhere. I mean, very rarely do we have whole numbers just chilling out. And so it's going to be important that we understand how to add and subtract fractions in real world situations. So let's jump right in. Maria painted 7/12 of a fence on Monday and 1/4 of the fence on Tuesday. Fraction of the fence remains unpainted. Well, this is a multi-part question here. So first, we figure out, well, how much is painted, right? So if we think about that first, we know she painted 7/12 on Monday and 1/4 of the fence on Tuesday. So this is how much has been painted. So if I want to add those fractions together, I know I need common denominators. And 12 and 4, well, my common denominator will be 12. So my first fraction doesn't change at all. My second fraction, well, 4 times 3 gave me 12, so 1 times 3 gives me a numerator of 3. That makes, well, denominator stays the same, 7 plus 3 is 10. If I simplify that, 10 and 12 are both simplifiable by a factor of 2, and I end up with 5/6. So the fence is 5/6 painted. Well, if 5/6 is painted, how much is unpainted? Well, 1 is the whole fence, right? The whole fence is represented by 1. And I painted 5/6. So the answer is how much remains painted. I need denominator of 6 in order to subtract. Well, if I want it to be 1 whole, 6 over 6 is 1. And that means 1/6 of my fence remains unpainted. So that problem right there had a little bit of adding and subtracting, which isn't always the case, but in this case it is. So multiple steps, just got to figure out what they're asking. All right. The second one, a family drove 7/10 of their planned trip distance on Saturday. On Sunday, they only drove 1/6 of the distance before stopping. How much farther did they drive on Saturday than on Sunday? So we know that they drove further on Saturday. So we're going to take Saturday minus Sunday, and that'll let us know how much farther they drove on Saturday. So on Saturday, they drove 7/10 of their trip. On Sunday, they drove 1/6 of their trip. We want to know how much further, that's the difference between them. And we know to subtract fractions, we must have common denominators. So when I look at 10 and 6, well, what number do they both go into? And if I think about 10, my multiples of 10 are 10, 20, 30, 40. Well, I can see quickly both 10 and 6 go into 30. So I'm going to change my two fractions to have a denominator of 30. Okay. Now, in the left fraction, 10 times 3 is 30. So 7 times 3 is 21. 6 times 5 is 30, so the numerator is 1 times 5. So to make these a little bit easier to see, I have 21 over 30 minus 5 over 30. My denominator stays the same, and I subtract my numerator. 21 minus 5 is 16. Well, hopefully you look at this and say, hey, 16 and 30 both share a common factor of 2. So if I take 16 divided by 2 is 8. 30 divided by 2 is 15. And so the family drove 8/15 of the trip farther on Saturday than they did on Sunday. All right, let's go ahead and have you try this one and then come back and check it out and see how you did. So you pour a ½ liter of apple juice into a pitcher. Then you add 3/8 liter of cranberry juice. That sounds delicious. If the pitcher can hold 1 liter, what fraction of the pitcher is still empty? So this is very much like that painting question we had in, right? So we know we poured in a ½ of a liter and then 3/8 of a liter. So this is how much is in, right? This is filled. This is how much is filled. Well, if I add those together, 2 and 8 will give me a common denominator of 8. My second fraction doesn't change. I love those. On the left side, 2 times 4 gave me 8, so 1 times 4 gives me 4. I add those together, and my pitcher is 7/8 of the way filled. So the question is, what fraction is still empty? Well, if I have the whole pitcher and it's 7/8 of the way full, well, subtracting from the whole pitcher will tell me the fraction that is still empty. So if I want common denominators, well, 1 with a denominator of 8 is just 8 over 8, right? Anything over itself is 1. So when I take 8 over 8 minus 7 over 8, I get 1/8. So the amount, the fraction of the pitcher that is still empty is 1/8. And let's do just one more, another you try it. A baker needs 1/4 of a cup of sugar for a batch of cookies and 1/3 of a cup of sugar for a glaze. This also sounds very good. How much sugar does the baker need in total? Well, I'm going to need 1/4 of a cup for the cookies plus 1/3 of a cup for the glaze. Okay, so I look at 4 and 3, common denominator. Well, 4 and 3 both go into 12. So 4 times 3 gives me 12, so 1 times 3 is 3. In my right fraction, 3 times 4 is 12, so 1 times 4 is 4. My denominator stays the same. I add the numerators, and our baker is going to need 7/12 of a cup of sugar for this baking extravaganza. So I hope that helps adding and subtracting fractions in the real world.